This is NovaMaker PLA Filament. I usually don't do filament reviews, it's just not my thing. But one of my favorite YouTubers, Thomas at Arduino Makes, did a review of the Nova printing filament that he got for Christmas. And he did such a great job, I had to head over to Amazon and get some of my own. Hopefully I can do as good a job as Thomas did on his review. Please check out his review here and go to his channel and check out all his great videos. He does an excellent job at explaining things, and he's only going to get better. So now, let's test all this stuff and see how we do. The first thing I noticed about this filament is they all have a little handle on top of the box. That's pretty interesting. I've never seen that before. So I ended up with some red, some blue, and some purple. This is all PLA filament, but the colors are really vibrant. Hopefully it transfers over to the prints. So from the sticker on the spool, it looks like they recommend 190 to 220. Pretty common PLA temps. The printing is done, and here's my armada of 3D benchies. Now we could do strength tests or heat tests, but I don't think that's really necessary. Most of the time if you're printing with PLA, you just want the easiest way to get a good looking print. Don't get me wrong, PLA is still a very functional plastic, but more than likely you probably don't expect it to perform in extreme situations. You just want a nice looking model. With that said, these benchies were printed on 5 different printers. One at 210C and the other at 190C, all with a 55C bed temp. All the slicer settings were the same, including a 0.2 layer height, 20% cubic infill, 2 walls, 5 top layers, 4 bottom layers, a speed of around 45 millimeters a second, all had a 0.4 millimeter nozzle, part cooling fans were used on all models after the first layer, and all were using Z-Lift. The only thing that was changed in Slicer from printer to printer was retraction settings. These are all adjusted per printer design. 4 different bed surfaces were used as well. A build tack-like sheet, glue stick, PEI sheets, and a print and Z skin. Now we'll get to the prints. All first layers stuck well, no curling at all, no surprise there with PLA. First we have the CR10 models. These were printed on top of a PEI sheet. This is the 210 degree model. This is a really respectable model. Very little stringing. All layers were very well combined and look very smooth. Very few errors on this one. Now the CR10 at 190. The 190 model still looks fairly good, but there are a few missed layers where we probably could have used a little more heat. Next up we have the Anet A3. It was also printing on a PEI sheet. This is the 210 degree model. There is quite a bit of stringing on this model and maybe a few retraction issues, but all in all, looks pretty good. All layers combine well. Everything looks nice and smooth. Then we have the 190 degree model. Model still looks pretty good, some stringing, but something you will notice on the lower temperature models, they're not near as shiny as the 210 degree models. Then we move to the Anycubic Cossel Delta 3D printer. It was printing on a Print and Z skin. This is the 210 degree model. The model looks great. There's little stringing, but there is a few overhang issues on the bow. This is probably because of the feed rates that are set in the firmware. Even though the slicer speeds were the same as the rest of the models, it does move a lot quicker than the other printers. These models also finish in about a half hour sooner than all the other printers. Still on the Delta, we move to the 190 degree model. Very little stringing, still the same overhang issue. You'll notice the duller finish with the cooler temperature, and there are just a few skipped layers. You can see it on the back hole right here. Then we move to the Monoprice Mini. The Mini prints on a build tack-like sheet, and it's the only printer I use the purple PLA on. This is the 210 degree model. The camera doesn't do this filament justice. It's a very cool color, and it's almost transparent. Because of the transparency of the plastic, you can see a few minor defects through the model. It missed just a few of the overhangs as well. There are a few retraction issues back here on the corner, but all in all, came out pretty good. Then we move to the 190 degree model for the Mini. The Mini just couldn't keep up at 190 degrees. There are a lot of missed layers due to under extrusion. Then finally the Anet A3. This is the only direct drive extruder in this lineup. It prints on glue stick on top of a heated aluminum plate. This is the 210 degree model. There is slight stringing, but I can't believe how well the A3 did with this filament. The bow is completely smooth, and there are no underhang issues. The portholes are almost perfectly round. Even the bridging on the wheelhouse looks pretty good. And you can almost read the words on the back. Then the 190-degree model for the A3. Almost as good as the 210, still the same amount of stringing. You do get a little duller finish than you would at the higher temp, but the bridging still looks good, and all the holes appear to be the correct size. Now that was a lot of benchies. The printer that seemed to do best with this filament was the Anet A3. 210 degrees C looks a little better on average than 190 C. All three colors I tried look great. The red and the blue are really deep colors, and the purple has this cool translucent effect. From what I've seen, for $18 US per kilogram, you can't go wrong. It's currently available in 8 different colors on Amazon. So what did me printing all these benchies prove? Not a lot, really. It proves that you can print this PLA on a lot of different machines pretty easily. But with a few setting changes or tweaks, you can print all these models flawlessly on any of these printers. The real purpose of this video is to thank Thomas for introducing me to NovaMaker Filament, because I had never heard of it before, and it would make a great choice for your staple filament. Again, please check out Thomas's review of this filament and all of his videos. His channel info will be linked in the description below. I hope this video helped you and my fellow makers. If you like this video, please consider giving it a thumbs up, subscribing to my channel, or subscribing to Arduino Makes, Thomas's channel. Thank you for watching, and thank you for participating in this community.